The size of the grounding electrode conductor, or GEC, as specified in the National Electrical Code, or NEC, section 250.66 is indeed dependent on the configuration of the electrical service. In a scenario where you have a 400 amp service, the required GEC size can vary based on whether there is a single 400 amp disconnect or multiple smaller disconnects that total 400 amps. For a single 400 amp service disconnect utilizing 500 kcmil conductors, a 1/0 copper GEC would be required according to NEC table 250.66. However, if the same 400 amp service is configured with two 200 amp disconnects, and assuming 3/0 conductors are used for each disconnect, the calculation changes. The cumulative circular mil area of the conductors in parallel must be considered. Two 3/0 conductors have a combined circular mil area of approximately 335,600 circular mils. In this case, a number 2 copper GEC would be required per NEC table 250.66. The reason for this difference lies in the principle that the GEC is intended to provide a path for fault current back to the source, thereby facilitating the operation of overcurrent protective devices. The size of the GEC is related to the size of the service entrance conductors because it must be capable of safely carrying the available fault current. The NEC specifies minimum sizes for GEC based on the size of the service entrance conductors, as indicated in table 250.66. When multiple service disconnects are used, the code requires the GEC to be sized based on the equivalent size of a single conductor that would be needed to carry the total service current. This approach ensures that the GEC is adequately sized to handle the potential fault current. Several factors influence the appropriate size of the GEC, including firstly the size and material of the service entrance conductors. Secondly, the number and size of the service disconnects. Thirdly, the type of grounding electrode system being used. And fourthly, the applicable requirements of NEC section 250.66. It is important to consult the latest edition of the NEC and to perform the necessary calculations to ensure that the GEC is properly sized for the specific service configuration. This will help to ensure the safety and reliability of the electrical system. When dealing with parallel conductors, the NEC requires that the GEC be sized based on the equivalent size of a single conductor with an ampacity equal to the sum of the ampacities of the parallel conductors. This calculation ensures that the GEC is appropriately sized to handle the potential fault current in a parallel conductor installation. The grounding electrode system consists of the grounding electrode, such as a ground rod, ground plate, or underground metallic water pipe, and the grounding electrode conductor that connects the electrode to the service equipment or separately derived system. The grounding electrode conductor is sized according to NEC table 250.66 based on the size of the service entrance conductors. It's crucial to understand that the grounding electrode conductor is not intended to carry normal operating current. Its primary function is to provide a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses. This rapid clearing of ground faults minimizes the risk of electrical shock and equipment damage. NEC section 250.4 provides the general requirements for grounding and bonding. It emphasizes the need for effective ground fault current paths to facilitate the operation of overcurrent devices. The path to ground from circuits and equipment must be permanent and continuous, and have ample carrying capacity to safely conduct any fault current likely to be imposed on it. NEC section 250.24 covers grounding requirements for separately derived systems such as generators or transformers. These systems must be grounded in accordance with the same rules as service-supplied systems. The size of the grounding electrode conductor for a separately derived system is also determined by NEC table 250.66 based on the size of the derived phase conductors. NEC section 250.30 provides specific rules for grounding electrode conductors used with alternating current systems. It covers the materials, installation methods, and connection requirements for grounding electrode conductors. The grounding electrode conductor must be copper, aluminum, or copper-clad aluminum, and must be installed in a manner that protects it from physical damage. The grounding electrode conductor must be connected to the grounding electrode, and the service equipment are separately derived system using approved methods such as exothermic welding, listed pressure connectors, or bolted connections. NEC Section 250.50 requires that all grounding electrodes that are present at a building or structure be bonded together to form a grounding electrode system. This bonding ensures that all parts of the grounding system are at the same potential, minimizing the risk of voltage differences and ground loops. The bonding connection must be made with a bonding jumper that is sized in accordance with NEC Table 250.66. NEC Section 250.52 specifies the types of grounding electrodes that are permitted by the code. These include metal underground water pipes, metal frames of buildings and structures, concrete encased electrodes also known as UFRs, ground rings, and ground rods, and pipe electrodes. Each type of grounding electrode has specific installation requirements that must be followed to ensure its effectiveness. NEC Section 250.53 provides requirements for the installation of grounding electrodes. It covers the depth and spacing requirements for ground rods and pipe electrodes, as well as the connection requirements for other types of electrodes. Ground rods and pipe electrodes must be driven at least 8 feet into the earth and must be spaced at least 6 feet apart. The connection to the grounding electrode must be accessible and protected from physical damage. NEC Section 250.64 covers the requirements for grounding electrode conductor connections. It specifies the methods that can be used to connect the grounding electrode conductor to the grounding electrode in the service equipment or separately derived system. The connection must be made with approved methods such as exothermic welding, listed pressure connectors, or bolted connections. The connection must be accessible and protected from physical damage. NEC Section 250.68 provides requirements for the connection of the grounding electrode conductor to the equipment grounding bus or terminal. The equipment grounding bus or terminal is the point where all of the equipment grounding conductors in the electrical system are connected together. The grounding electrode conductor must be connected to the equipment grounding bus or terminal in a manner that provides a low impedance path for fault current to return to the source. NEC Section 250.70 covers the requirements for the identification of grounding and bonding equipment. Grounding and bonding conductors must be identified by a green color or a green color with one or more yellow stripes. This color coding helps to ensure that grounding and bonding conductors are easily identifiable and are not mistaken for other types of conductors. In addition to the requirements of NEC Section 250, there may be other applicable codes and standards that must be followed. These may include local building codes, utility company requirements, and industry standards. It is important to consult all applicable codes and standards to ensure that the electrical system is installed in a safe and compliant manner. Proper grounding and bonding are essential for the safety and reliability of electrical systems. By following the requirements of the NEC and other applicable codes and standards, it is possible to minimize the risk of electrical shock and equipment damage. It is important to remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you have any questions or concerns. Always energize electrical equipment before working on it, and follow all safety precautions. The information provided here is for general guidance only, and should not be considered a substitute for professional advice. Always consult with a qualified electrician before making any changes to your electrical system. Note that the specific requirements for grounding and bonding may vary depending on the jurisdiction and the specific application. It is always best to consult with the local electrical inspector or a qualified electrician to ensure that the electrical system is installed in accordance with all applicable codes and standards. The NEC is updated every 3 years, so it is important to use the latest edition of the code. The NEC is available from the National Fire Protection Association, or NFPA. The NFPA also offers training and certification programs for electricians and other electrical professionals. Proper grounding and bonding are critical for protecting people and equipment from electrical hazards. By following the requirements of the NEC and other applicable codes and standards, it is possible to create a safe and reliable electrical system. If you are not comfortable working with electricity, it is always best to consult with a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary safety precautions. Before starting any electrical work, be sure to turn off the power at the main breaker. Use a voltage tester to verify that the power is off before touching any wires. Wear appropriate personal protective equipment, such as safety glasses and gloves. Work in a well-lit area and avoid working in wet or damp conditions. If you are not sure how to do something, ask for help from a qualified electrician. Electricity is a powerful force, and it should be treated with respect. By following these safety precautions, you can help to prevent electrical shocks and other electrical hazards. When sizing the grounding electrode conductor, remember to consider the following points. Firstly, the size of the service entrance conductors. Secondly, the number and size of service disconnects. Thirdly, the type of grounding electrode system being used. And fourthly, the applicable requirements of NEC section 250.66. These considerations will ensure that the grounding electrode conductor is properly sized to safely conduct fault current and protect the electrical system.